but it is what it means. So these are the bars that we use. And we put a number on the inside. So the bars, this is important. They are like a grouping symbol. They're like parentheses. So if I had this going on inside of the bars, 5 plus a negative 3, you've got to figure out what that equals first. You don't take the absolute value of 5 and negative 3 and add them together. So this here would have to be equal to the absolute value of 2, which is how much? What's the absolute value of 2? This would be 2, yeah. And the absolute value of 6 is just 6. Because what absolute value means is the distance from 0. So if we graph this, we can make a really rough graph of it, but we want to take a look at it and say a few things about it. If we graph the absolute value function, what we have to do is we've got to take a bunch of values of x and y. So what I'm going to do is I'm going to graph like this. I'm going to say that y is equal to the absolute value of x. So here's the equation. Y equals the absolute value of x. So no matter what our x is, we take the absolute value. So if we start with a couple numbers, what's the absolute value of 0? 0. Thank you. Of 1? Of 2? Of 3? So on. Of negative 1? Negative 2? And of negative 3. Those are all equal to 2 and 3, or they're all equal to a positive number. So if you plotted these points, starts at the origin and then they form a straight line. And where basically the x value is equal to the y value because positive x's give positive absolute values. And then if we did the negative side, it's going to be like this because we always have a positive value when we come out of the absolute value bar. So that's kind of a simple review of what absolute value is all about. That's what the graph looks like right there. Now, a way to read this graph, if, for example, I wanted to look at the absolute value of 3. 1, 2, 3. That's this number right here, isn't it? And if I looked at the absolute value of negative 3, that's over here, 1, 2, 3. That's this, a negative 3 comes out as a positive. So for this value right here, when y is equal to 3, there's two solutions. There's this, and there's this. So if we drew a horizontal line across like this, and that horizontal line was y equals 3. Remember, all horizontal lines are y equals something. Vertical lines are x equals. But if we drew a line across here where y is equal to 3, we could say, well, when y is equal to 3, there's two solutions. So in this equation over here, if 3 is equal to the absolute value of x, this is a big concept here now. If we think backwards, we're asking ourselves, what numbers could x be that give 3 for an absolute value? So what could be inside of here? Negative 3 and 3. So that's how we write our answer. We write x is equal to negative 3 comma 3. In other words, there's two choices for x. Two inputs give one output. So two different numbers can give us an answer of 3. And the book does a lot of this work where they say, well, if we're gonna look at solutions, we're gonna draw a horizontal line for what our solution is that we're choosing. In this case, y equals 3. And then we look at where does that line cross the absolute value equation y. You know, we did a lot of that kind of stuff over the last couple of years. You know, more simple way. You don't have to write this. But if you had an equation that looked like that, and then we drew a horizontal line where they crossed, that value of x is what you need to get this value of y. So this idea of intersecting lines, crossing lines gets played upon quite a bit. Here, there's two locations where there's an intersection, two answers, two solutions. But we don't always work with simple things like just a number inside here. We have variables. And the variable like this isn't always going to be alone. Sometimes that might be x plus 7. And when we do that to equations, it makes this shape of a graph move around. It slides left and right, and it can go up and down. And over the years, you'll learn more and more about that. But first example that they give works with that idea. I want to take a moment to put this up. I think that this is worth sitting on and discussing and pointing at it and such. So here they've got a graph, and they're using this equation. And the equation works like this. It says that y is equal to 6 minus 2x. So we're looking at the graph on page 235. We have that on the smartboard. You can look at it as well if you're looking at it with us. Now, it says that they want us to consider this graph, which shows this equation, and then they also throw into this a second equation where y equals 18. And they want us to use the graph and use algebraic properties to solve this. So we got to solve it two different ways. When they say use the graph, what we do is we just look at it. So this, if you put this on your graphing calculator, if you put the absolute value of 6 minus 2x, this is what you would get. Why don't you do that? Put that into your graphing calculator. Where is it? You need it all the time. We've been using it more and more. I'll give you this one to use for now, but don't forget to give it back to me, please, okay? So do you guys remember how to put absolute value in? Have we done that yet this year? So you want to go to y equals to begin with, and then to get the absolute value bars, what do you do?
Go to math,
Math, and then go
1 to the right.
1 to the right to NUM. First one, you just hit enter, and then you have the absolute value bars. Then you can type in 6, subtract 2x. So why don't you just change your window to go from, you know, I don't know, like maybe negative 10 or something to maybe positive 20. And then your y, make it a little bit negative, like negative 5, so you can see the bottom scale. But then maybe make it go up to 25.
you want the y minimum?
Oh, what did I do? Y, I went from -5 to 25. There you go, and 2 minus, or 6 minus 2x. Yep. And then go to your window. And we did -10 to 20 on the x. Yeah, max is 20. My scale's 5 on it, doesn't really matter so much. But then the y minimum is -5. And the maximum is 25. And then you graph that, it should come up. You do okay? Yeah. And then move over to negative. And the first one is ABS, absolutely. And you can do 2 and 6x. What was I saying, 6 minus 2x, you have it right. That's fine. Graphing like that. Okay, so once you have a graph on there, you good with Jackson? Go to your y equals and add a second equation, y equals 18. So we're just going to look for a horizontal line of 18. And then you're going to graph it, and you'll get a horizontal line shooting through, right? So that means there's 2 solutions. So if you hit your trace button, you can slide along one of your equations, and you can get an approximation of what these 2 solutions are. What do they seem to be about?
12x equals 12 and y
12
is 18.
and 18?
Yeah.
12 is the x value, 18 is the y value if you're reading off the bottom.
Yeah.
So you should actually, if you went to the left-hand side over here, you should get like a -6.
Oh.
Yeah, you see here, so you have a -6, and then you have a 12. So if you look at it, they're not symmetric numbers, are they? It's not like to the right of 0 and to the left of 0. They're off. This is -6 and that's 12. And that's because of this here. This 6. That's what changes that. The 2 makes it steeper than the first graph that I was showing you. So here's something you can do. Go to your table. Second in the graph button, you go to a table. And you might need to start your table like at 1 or something. I'm not sure where your table gets started, but can you see values that are, yeah, so then if you scroll up and down, you want to look where your blue and your red numbers are both equal to 18. At -6 and at positive 12. You get way down to 12 and they're both 18 again. So you can use the table to find your solutions as well. So that's doing it on a graph. So we know on the graph that we're going to be looking for that -6 and positive 12. But now algebraically, this is the hard part. This is challenging. There's a first step that is really easy for students to miss. And they, it's like all the way through. I get this even in Algebra II. Here's the pretense. This number, 6 minus 2x, once you calculate what it is, then you take the absolute value of it. So in this case here, you could get a negative number inside of here, because when it comes out it's positive. But you could also get a positive number in here, and then when it comes out, it still is positive. So what we need to solve is we need to solve 18 is equal to the absolute value of 6 minus 2x. So we have to do this twice, because this number could be a positive 18, or you could have a negative 18 in here. negative 18's absolute value is also 18. So we begin like this. This could be equal to 18. This could be equal to negative 18. And then we do inverse operations and we solve it. So, let's do the one on the left first. Tell me what to do.
Subtract 6.
Subtract 6. So that's 12. Negative 2x. Divide by negative 2. X equals negative 6. There's your first solution. Now over here, subtract 6. Negative 2x equals negative 24. Divide by negative 2. Negative divided by a negative, positive. There's your 12. So this is doing it algebraically. And what we did over there is doing it with the graph. And that's what the example's asking you to do, both ways. The key to this is that there are two solutions. There's a positive and a negative number that can be inside of that absolute value bar. And that's why we have these two solutions here. Okay. Then, so that's equations of equality. Equations of inequality get handled the same way. We just follow the example that they give us here. So they have 8x plus 24 inside of the absolute value bar. 8x plus 24. And that value's absolute value is going to be less than or equal to 40. So they want us to solve it using algebra and then graph our solutions. And when we graph, in this case, because we just have one variable, we're talking about graphing on a number line, you know, with an open circle and a closed dot and the shading. Okay, so we do essentially the same thing, but we have to really watch, like when we divide by negatives and multiply by negatives, because you have an inequality symbol. So this number that comes out of here can be either positive or negative. So in this case here, the 8x plus 2 could be less than or equal to a positive 40. We solve it that way. I'm going to get rid of this geometry words. And secondly, 8x plus 2 can be less than or equal to negative 40. So, subtract 2. 8x is equal to 38. I'm sorry, less than or equal to 38. Divide by 8. Less than or equal to, well, let's see, half of 38 is how much? 19. So let's just call it 19/4 for now. Then we're going to come over here, and we've got a negative 40. So 8x less than or equal to negative 42. What's half of 42? Negative 21 over 8. error. You working in pencil?
Yeah.
Yeah. So we take the positive out of here, it stays as it is. But when we take the negative out of here, we have to change the direction of the inequality. Everything goes like this. Everything goes the opposite direction.
I thought it was only if you divide.
Yeah. Let me show you why. Let me put something on decimals real quick. Okay, so I'm gonna flip the direction here. Actually, I can just write it this way. I can say the absolute value of 8x plus 2 is less than or equal to 40. So I'm gonna say y though. Oops, this isn't making sense. There we go. Less than or equal to y. There we are. So this is the whole graph. And what they're saying is that anywhere that there's a shade, that's an answer. So if we're going to say less than or equal to 40, that's going to be from here on down. Which, yeah, let me see if I can change the x-axis a little bit here. I just want to do like negative 20 to positive 20. There we go. Okay, so you see 40 is right here. So these are counted by tens. So this is 40. So this is our limit. The answers that we get have to be less than 40. So all of this, what I'm shading as blue, these are all answers that are solutions. So in order to get this number right here, you use that x value. In order to get this number right here, you would use that x value. So all of our answers fall when we want to get to less than or equal to 40. All of our answers have to fall from this to this point in x. So 2, 4, this is about negative 5. This is about positive 5. They have to fall in between these two values. So take a look at this here. What's 19 divided by 4? Yeah, what's the mixed number? How many times does 4 fit into 19? No, not on your calculator.
No, I just did something with it.
What?
2.5 times.
More than 2.
4.
Yeah, 4 times 4 is 16.
Oh.
With a remainder of 3 is 4 3/4. So that's about 5.
I don't know.
How many times does 8 fit into 21?
That should not be 4.
It should be 4, shouldn't it? You're good.
That's 5 and 2.
So that's a negative 5 and a 4. So between these two numbers is where we can have, oops, that was bad. Between those two numbers, we can have things shaded. So you know, here's your 40. We come straight down here, and that's a negative 5 and a 4. here's where 40 is, and that's a positive 4 3/4. So if you were to look at this as the x-axis all the way across the bottom, beginning from here to here, and any of these numbers in between, those are all your solutions. So here's what we did on Desmos. So here's 40, we graphed this equation. The answers go from negative 5 1/4 to positive 4 3/4. That's what gets graphed. So from 0, this is x. You can just put a mark down here and call it negative 5 1/4. Put a mark up here, 4 3/4. It's closed on both ends because it's or equal to, and it's shaded in between. So there's the graph. Here are the two endpoints. And then the way this gets written, the way this would get written, you would say that x is in between these two numbers, negative 5 1/4 and 4 3/4. And you use the inequality that points in the same direction. So your x is bigger than the negative, so x is larger than, and this says x is smaller than. So the trick to this one is that when we solve for the negative value, we switch the direction of the inequality. You won't see a lot of those, but they exist.
That's
Yeah, that's tricky stuff. You won't see a lot of it. You'll see a lot of these with an equal sign. And with an equal sign, you're just taking away the shaded. See, these are all these numbers that could result in something that's smaller than 40. So smaller than, squeezing in. And if the absolute value is closer to 0, that's why we have to switch this. Here the absolute value is closer to 0 also, but we're dealing with positive numbers as opposed to negative numbers. You can do this on your graphing calculator too. You can do shaded graphs if you want to. You won't need to for the homework, but you're able to do it. And I'll just leave it at that. If you want to learn how to do it, just Google it's a couple of settings that you have to change. It's very simple. And then when you go to y equals, you get to change your equal sign to any inequality that you want, and it shades and everything. Later on in the year, I'll show you more of how to work with that. So, your work. This is it. 1 to 7, 11, 13, 15, 17, and 22. And then tomorrow we'll start reviewing. And we'll begin our review with the self-test.